So does it work in human subjects? And this is still a relatively open question, but not so open again, because there have been, during the past 10 years, a number of studies which confirm that similar effects can also be seen in human subjects. So this is a Swedish study looking at 5,925 older women, which means in this case around the age of 70. They were then followed for a 10-year period. They were characterized to begin with, before the 10-year period, by a number of different measures. One being what kind of diseases they had, what kind of socio-economical class they belonged to, hypertension, etc., etc. It's all mentioned here. And then, in addition, they were then divided into these 4 groups based on the amount of exercise that they were doing. So the lowest amount of exercise and the highest amount of exercise that you have here. Otherwise, these 4 groups were very similar in terms of age, in terms of other diseases, in terms of socioeconomic status, etc. And then they followed them for these 10 years. And during that 10-year period, the ones who were in the lowest group, their cognitive functions declined by 4.5%, whereas those who were in the highest activity group declined by around 3%. So it's a difference of almost 1.5%. Or if you see the decline here as being 100%, then it's more than a 25% difference. So at least 25% of your decline in cognitive abilities when you become old can be counteracted by exercise. This is quite a lot. So maybe you can even become young again, maybe. But it's not really a conclusive study. So the most conclusive study, I think, is this one. It's published in 2009 in Proceedings of National Academy of Science in the States. It's a study where some people up in Gothenburg assembled 1.5 million Swedes. They didn't investigate them themselves. They simply went into the registries, starting out with, what is it called? When you get drafted for the military at age 18, all Swedish men are basically going through 2 essential tests here. One is an intelligence test, another one is a physical test. So they actually do a maximal oxygen uptake test as part of the physical examination that they have, which I think we should do here also, just so that we could have some data on it. Then they also got all the information about which grades they had got from primary school, and they were able to follow them for up to 36 years in various registers to see what kind of education they had had gotten, what kind of occupation they had, and what kind of income they ended up having. They also looked into the twin register, which is one of the most important things. So just looking at the whole 1.5 million that they had here, and looking just at the global intelligence from the intelligence test and their cardiovascular fitness score, they found a very, very nice linear relation. So basically, the more intelligent you are, the more fit you are, or the other way around. A problem here, obviously, is that you don't really know which direction it is. It could be that very intelligent people make sure to do exercise, or that people who do exercise become very intelligent, or that some other factor determines that people who are generally very intelligent are also quite fit. It could be just socio-economical status, which determines that if you have a good social background, then you tend also to be more intelligent and more fit, whatever. So we don't really know. But what is interesting is that they also did the same thing in relation to muscular strength. And you see a relation for the very lowest muscle strength, but not for stronger muscle strength. So it's not like if you're very strong, you're also very intelligent. It's certainly true for the first part here, but that's maybe just in order to have some basic level of cardiovascular fitness, you need some muscle strength, because if you have absolutely no muscle strength, it's kind of difficult to also have a good cardiovascular fitness. So these two will, to some extent, fit together. So that's all very well, but that had been demonstrated before in many studies. This is just much more than in any other study, but basically the same finding has been reported before. What was really the interesting thing is that within these 1.5 million, they found 1,400 monozygotic twins, which is really interesting because it means that they have exactly the same genes, and therefore with this high number you can really start to do statistics to see to what an extent it is the genes which determine the intelligence here, or whether it is some other environmental factor. And this is what they started looking at. And the interesting thing here is that when you look at these twins and look at what they call non-shared environment, then you get a factor of 0.79. So that means that 80% of the difference in monozygotic twins in intelligence is determined by non-shared environment. What is the non-shared environment? This is simply how much exercise they do. So basically, if you find two twins, monozygotic twins, and they differ in intelligence, and then you start looking for what is the reason why they differ in intelligence, then it comes out that it's because one of them is physical active, the other one is not. So it's simply that one of the twins is down here, the other twin is up here. So 80% of the difference in intelligence in monozygotic twins is explained by exercise. That's really a lot, much more than anybody had expected it to be. Yeah.
Og det kunne ikke hænge sammen på den måde, at så grunden til, at den tvilling, der så var klogere, eller at der var sådan bedre til sport, for eksempel, det var fordi han var klogere af nogle helt andre årsager.
It's absolutely still possible that the causal relation goes the other way, that because they're intelligent, they decide to do sports. But it's still a close correlation between the two. So my feeling is that with the background that we have in the animal experiments, where we can actually demonstrate it through intervention, that we have a mechanism to explain it. But obviously what we need to do here is some kind of intervention study and take the 1,400 monozygotic twins and split them in two, and then let some of them do exercise and follow them for 10 years. So I'm just saying this is the two best studies that we have available, because one of them is kind of an intervention study. They start out by dividing them into 4 different groups, and then they follow them for 10 years to see what then happens to them after having done exercise. This is also sort of, they follow what is happening to these people. And again, it can be discussed what comes first, but if you look at education, occupation and income, all of them correlate with exercise. So those who at the age of 18 were the most fit also end up with the highest education, are generally in jobs which are much more well paid and therefore have a higher income than those who have done less exercise at the age of 18. So as a predictor of your what is going to happen to you in the rest of your life, just looking at exercise at the age of 18 is quite efficient. And that's astonishing. But you could say that that's just because there's such close correlation to the intelligence. And then it's the intelligence which makes them do this. So again, we can't really tell them apart, but they come close in hand. And with the mechanisms that we can describe in animals, it seems to be there is a case for it.